class. Today we're going to take a look at how you would solve equations by factoring. And when you do that, you use a principle that we're going to have called the zero principle or zero property. And basically that states that if you have two things that multiply to get 0, so here we have a times b equaling 0, then either a has to be 0 or b has to be 0, because the only way to get 0 for an answer when you multiply is to have either one or the other of the factors be 0. Now that brings us to taking a look at equations like this. Now, whenever you have an equation that you're going to be solving by factoring, you need 0 on one side in order to solve it using that method. So the first thing we need to do when you see any equation, especially this one here, is you want to simplify and get 0 on one side using what we know from basic algebra. So in this particular problem, the first thing I'm going to do is distribute that x. And x times x is x squared. X times negative 8 is negative 8x. When I distribute that x, I notice that I have an x squared. And anytime you have an x with an exponent higher than 1 in your particular problem, factoring might be one of the ways you choose to solve it. Sometimes things aren't factorable. Up until now, everything is going to be factorable. When we get into the next chapter, we might find some things that aren't factorable. But everything you're going to deal with right now is going to be factorable. So that tells us that we need to get 0 on one side so that we can use our zero factor property. So we're going to go ahead and move our negative 15 over by adding 15 to both sides. Doing so makes those cancel, so we have 0 on the right side. And on the other side, we have x squared minus 8x plus 15. Now, what we're going to do is take this left-hand side here and factor it. When we factor it, we'll be able to set up a situation like this zero factor property where we have two things multiplied to get 0. So I first look to see if there's anything in common here, following the same two-step process we've been looking at for factoring. And I notice nothing's in common with any of these terms. So then I ask myself, how many terms are there? And there's 1, 2, 3 terms. And I notice that the first term has an a for a coefficient. So that means I can use my shortcut. I need to look and find two things that multiply to get positive 15 and at the same time will add up to negative 8. And I notice that negative 3 times negative 5 makes positive 15 and negative 3 plus negative 5 makes our negative 8. So that means that this left-hand side over here factors into x minus 3 times x minus 5. Now I have two factors that when multiplied I get 0. That means that one or the other of those factors has to be 0, which means we're probably going to get two possibilities of answers here. Unless those factors are identical, you will probably get multiple factors or multiple values that could be solutions to your particular problem. So I'm going to first take this x minus 3 and set it equal to 0. And then I'm going to take this x minus 5 and set it equal to 0. We need to solve both of these to get the two possible solutions. If I look at my first one, I'm going to add 3 to both sides, and x ends up being 3. This is one possible solution. The other possible solution is going to be solving this by adding 5 to both sides, which makes x equal 5. So x can either be 3 or it can be 5. That means if we take either of those numbers and plug it back into the original equation, it should give us a true statement. Oftentimes you will actually write your answer out as a solution, or saying in a sentence, saying that the solution is positive 3 or 5, like that. Or you can set up a solution set using set brackets of 3, 5. These are all perfectly fine ways to write your solution. Now, let's take a look at how we can use these equations to help us solve problems. You'll have many story problems that set up equations that in order to solve you have to use factoring. So we're going to go ahead and take a look at a couple of those and see how you might deal with them. The first one we're going to deal with is dealing with a rectangular garden. And so let's go ahead and make a picture of this garden. So here's your rectangular garden. Now I'm going to read the problem to you. It says the length of the rectangular garden is 5 feet greater than the width. So why don't we label this as the length and this is the width. 5 feet greater than the width means that the length is going to equal w plus 5. So now we have things labeled, and reading on, the rest of the problem says that the area of the rectangle is 300 square feet. So we also need to recognize that the units here are feet, so that is going to be in feet and that is going to be feet, and it says that the area is 300 feet squared. Now, we need to remember how you get area of a rectangle. Area of a rectangle is length times width. And we want something that only has one variable in it. So rather than using L and W, how about if we use the W plus 5 and the W? That's going to give us W times W plus 5 is going to equal our 300. This equation will help us solve for W, and then we can find our L also. So we're going to go ahead and solve this by doing a very similar process we did in our problem that was given to us. We're going to distribute our W squared plus 5W, and that equals 300. Now, since we have a term that is squared, that's our clue that maybe we should do factoring on this, and we should get 0 on one side. So let's go ahead and subtract 300 from both sides. That gives us 0 over here, and over here we have W squared plus 5W minus 300. Now we need to factor, so we need to take a look at the factors of negative 300 that'll add up to positive 5. Now you might be looking at 300 saying, wow, that's huge, and I have no idea what's going to add up to 5. So off to the side, you're going to do your negative 300 and list things, but we don't want to start at 1 times 300 because that's not even going to be close because we're looking for a 5. So how about if we start with something a little larger, like maybe let's start with 10. So we have 10 times negative 30, or we could have negative 10 times positive 30. And then going up, 11 won't go in, and 12 won't. Neither will 13 or 14, but 15 is going to go in 20 times. So we have 15 times negative 20, or negative 15 times a positive 20. And notice that starting up a little larger, we were able to get to our 5 quicker because negative 15 plus 20 is that 5 that is our B. So we can go ahead and factor this since there's 3 terms and a 1 for our A. We can use our shortcut and make this W minus 15 times W plus 20. Now, one thing to keep in mind, in story problems, you will often get 2 solutions. One of them will make sense and one of them won't. And in this particular situation, we're looking for a length. It does not make sense to have a negative length. So one of these may be negative, and that one will not be our solution, and the other one will be positive, and that will be. So let's go ahead and set each factor equal to 0 and solve. We have w minus 15 equals 0. The other equation we'll solve is w plus 20 equals 0. Now, when we solve this, we're subtracting 20 from both sides. Notice that that gives us a negative 20 for an answer. Doesn't make sense to have that negative answer, so that's not the solution. On the other one, we add 15 to both sides, and that makes w equal to 15, and our units are in feet, and that does make sense. So that means that this width here is 15 feet. Now the length has to be 5 more than that, so the length over here is 20 feet. So the dimensions of our rectangle are going to be 15 feet by 20 feet. Now let's take a look at another type of problem that we can solve by factoring. For this particular problem, we're going to be taking a look at a problem where we have an object flying through the air. And when an object flies through the air, it makes a specific shape. So pretend that this happy face is a ball, and you throw it. When you throw it, it makes this shape here. Now that shape is what we call a parabola. And a parabola is the shape of all these graphs where you have a quadratic where your variable with the highest exponent is a 2. So these equations lend themselves to having problems where you're talking about objects flying through the air. Now we're going to give this problem a formula for an object that's flying through the air. This is going to be a ball, and it's flying through the air, and the height at any given time, where height is going to be in feet and time is going to be in seconds, is going to be found using the formula negative 16 t squared plus 20t plus 300. Now let's say that you are given this formula and we want to know when this ball is going to hit the ground. Well, we need to think about something. When the ball is on the ground, how high above the ground is it? Well, when it's on the ground, it's 0 feet above the ground. So that means that when it's on the ground, this h here is 0. So we're going to go ahead and make h 0. Now, if you were also doing this particular problem in function notation, keep in mind that this h might not be h. If we were in function notation, it might be h of t, where h of t is the height of the ball. Having just the h there and having the h of t there, you're going to treat this problem the same. This h of t would be the height of the ball, and the height of the ball is going to be 0, so we're going to place a 0 in there. If you have just an h there, you do the same exact thing. So we have 0 equals negative 16 t squared plus 20t plus 300. Now, for this particular problem, we already have 0 on one side, and it's already simplified. So we can go ahead and factor. Now, one thing you want to keep in mind is when you're factoring and you're solving an equation by factoring, if there's a number that divides evenly into everything, it is okay to divide everything in an equation by that number. So I noticed that 4 divides evenly into everything on this particular problem. And I also notice that this first term here is a negative 16, and I don't really like to have a negative leading coefficient. So rather than dividing everything here by 4, how about if we divide everything by -4 to make that a positive value? So we're going to go ahead and simplify our problem by dividing everything by -4 all the way across. 0 divided by -4 is going to be 0. The -16 divided by -4 is going to give us a positive 4t squared. And then 20t divided by -4 is -5t. And 300 divided by -4 is going to be, you'll notice that one way to do this in your head is that 100 goes into 300 3 times, and 4 goes into 100 25 times. 25 times 3 gives you 75, so this is -75. So that's one little trick there for you for calculating those without grabbing a calculator, which many of you might have been doing. So now I have much simpler numbers to deal with. I also notice that I still do not have a 1 out here, so I need to do my long process. We're going to need to do 4 times -75. So we will go ahead and do that over here, and we have 4 times -75, and that ends up being -300. Now I need to list the factors of -300, and I need to find factors that add up to this -5. And you might have noticed in the last problem we just did, we had the same number, but we were looking for a +5 instead of a -5. And in that problem, we found that 15 times a -20 was a -5. We actually used -15 and a +20 to get the +5. So these two numbers here are going to be the pair that we use. We're going to take this -5t here and separate it into 15t plus a -20t because that's where the -5t came from when the two things that we're going to come up with were FOILed. So we have 15t plus a -20t minus our 75 here, and we're going to include the 4t squared out here and carry down our equals 0. Now we have 4 terms, so let's group them. We're going to group the first 2 and the last 2. We need to look at what's in common with the first 2 terms, and the first 2 terms have a t in common, so let's factor out a t. That leaves us with 4t plus 15. And be sure to carry down your equals 0. On the second 2 items here, I noticed that 5 goes into both of them, and they're both negative, and in the first parentheses we had both positive. So how about if we factor out a -5? If we factor out a -5, then -5 into -20t will leave us with a +4t, which matches the +4t in the first parenthesis. And -5 into -75 will make a +15, which matches the +15 in the first parenthesis. Now these parentheses match, and we can treat this like one large term and this like one large term. Both of them have a 4t plus 15, so let's factor out the 4t plus 15. And we're going to carry down our equals 0. When you factor out that 4t plus 15, it leaves you with a t minus 5. Now we need to set each factor equal to 0 and solve. So if we set this first one here equal to 0, the 4t plus 15, I notice right away that when I move my 15 over, I'm going to be subtracting 15 from both sides. And before I even divide by 4, I can tell I'm going to end up with a negative value, and it's not going to make sense to have negative time. So this is not the factor that we're going to need. We're going to actually need this factor over here, the t minus 5 equaling 0. Because on this one, we can add 5 to both sides. And we get t equals 5. And that means that after 5 seconds, this ball will hit the ground. So our answer to this would be the ball hits the ground in 5 seconds.